Welcome to Hands-on Study Hub. Today we learn about the block transfer in the 8051 microcontroller. In this video, I will clearly explain about the block transfer program in the 8051 microcontroller. Without any further delay, let's get started. The 8051 microcontroller has 4 register banks. They are Bank 0, Bank 1, Bank 2 and Bank 3. Each bank contains 8 registers. They are from R0 to R7, which are general purpose registers that can hold only 1 byte of data. Okay, in this program, we used R0, R1, R2 as a registers. Here R0 and R1 are used as a pointers and R2 is a counter register. Okay, so let's get into the program. Move R0, #30H. It means load R0 with the source address. Next, move R1, 40H. It defines loads R1 with the destination address. Okay, the main aim of block transfer is nothing but it is used to copying the data. It can be array, buffer, etc. So copying the data from source address to destination address. Okay, here the source address is R0 register and the destination address is R1 register. So next, move R2, #0AH. Here R2 is a counter register. So next, move A, @R0. Here @ symbol indicates it is a indirect register addressing mode. Whatever the data which is present in R0, it need to be transferred into accumulator. Okay, next move @R1, A. Whatever the data means, whatever the input data which is present in accumulator, it need to get copied into R1 register. Next, after copying the 1 byte of data, the memory location must get incremented to next memory location. For that purpose, here we are using the increment R0 register. Okay, here 30H is a source address, 40H is a destination address. Here the 30H is copied into R0 and 40H is copied into R1, right? So we need to use the increment R0 register, increment R1 register. Okay, next, after incrementing the 1 byte of data from memory location to another second memory location, the count need to get decremented. Dear all, as we all know, here we using the 10 bytes of data. Okay, means here the counter register is R2 register. It's need to get decremented from 0A to 09. For that purpose, here we are using the decrement jump if not 0. It is an instruction. Okay, after decrementing the 1 byte of data, it's need to get jump to the back. Okay, after jumping it to the back label, again the iteration will be start. Again move A, @R0. Now the two data will be transferred into R0 register. Okay, next, the transfer data means the copied data will be again copied into where it's a 40H register, right? So like this the iteration process will be repeated until the R2 means 0A. 0A will until decremented to 00. So 0A count decremented to 00 until the iteration process will be repeated. All the bytes of data which is present in 30H register will get copied into 40H register. So this is the process. Here I consider 10 bytes of data. Okay, depending upon the question, you can here give the count register. It can be 05, 0A. Okay, depending upon the question. In case if the question they asked use the 5 bytes of data, in that case here you will use the instead of 0A you will give the 05. Okay, so this is the before execution and this is the after execution. So now let's move to the practical execution of the block transfer program. So this is the Keil simulation. So this is the interface. We will get the Keil simulation process. Now then click on project and now click on new microvision project. So now give the name called means file name. Here I will give the it's a transfer and I will save it on the desktop. Next save. So this pop-up will be appear. So now you guys need to give the microcontroller device name. Okay, here we are using the 𝐸89C51 as a microcontroller. Then click on here and click on next and no. Now you need to write the program, right? For execution you need to write the program. For that purpose click on file, click on new and you need to write the program. Here guys as earlier I copied the program, so that's the reason again I copied here, I pasted here. Okay, so next you need to save the project. Okay, so save the project. Here I will give it's like transfer because this is a block transfer program. Here I am giving the shortcut like transfer. So for saving this program, here we will use the .asm as an extension. ASM means assembly language program. Okay, .asm. So save. I will save this here in desktop. So save. So you can observe here the color has been changed from normal black to color means RGB color. So next, after saving, right click on source group, option for source group, right click on source group. Okay, add existing file to source group. Now you need to check for your saved file means as earlier you saved the file, right, like a .asm extension. You need to add that file. So see here just I gave T, so here I got transfer.asm. Okay, so you need to add it. So you can observe here the plus symbol is appears, that indicates it's get added here. So next close it. See transfer.asm has been added to source group. Now right click on target, options for target, go for output. So click on create hex file. Okay, so now you need to check the errors whether the program has written right or wrong, means correct instructions are given or not. So for that click on here. So you can observe there is a one error. It's 8. Okay, means guys see here I missed it, the loop callback. So again guys you can check errors here. So here the error line also has been given. See 8. See here the number given 8, right? So decrement jump if not 0 R2 comma back. So back here I missed the loop call back, means it is asking that where I need to jump, where is the back label. Okay, so I given here after given this back instruction. Again you need to once save the program and again you need to check for errors. See here 0 errors, 0 warning. So click on build and click on rebuild. So after that you need to execute the program. For executing you need to click on debug and start and stop debug session. Okay, so here we used the 30H 40H as a memory location. So you need to click on memory window and you need to give the address called I:0x30H. So you need to give the input data 1, 2, 3, 4, 5, 6, 7. Here I am giving the input data. This is 8, 9, finally A. So guys, we are need to execute the program. So this is the 30H is the source address and 40H is destination address, right? So while executing the program, you need to run right here. This is the step by step. So see, after clicking this step by step execution of the program, you can observe here. Okay, from 30H to 40H the data has been copied. So here R2 is the counter register. See, the counter register has start decremented by 1 byte. Okay, so next you can observe guys, here the counter register has been decremented. So here the data has been copying right 30H to 40H. See guys, see simultaneously here R2 and output. You can observe the data has been copying and the count register has been decremented by 1 byte for each execution of the byte. See, here the R2 register is 00. Here the complete data has been transferred from 30H to 40H. See, 30H. So the 30H data remains as it is. So the data 40H. So see, the 30H data which has been copied from 30H to 40H. Okay, so that's how guys we implemented the block transfer in the 8051 microcontroller. I hope if you found this helpful, give a like and share my YouTube channel to your friends. Thank you.